are determinants? Why do we study determinants? What is the role of determinants in mathematics? And what is the geometrical interpretation of determinants in mathematics? So these are some questions that we will discuss today. As far as the class 11th and 12th is concerned, a student is only restricted up to the square matrix. Where there is square matrix, the student believes that it is a determinant. Whether it is 2 cross 2, 3 cross 3 or 4 cross 4. The rows and columns that should be same. This is the only notion up to which the student of class 11th and 12th, they are limited up to this knowledge only. But in today's lecture, we will be discussing about the geometrical interpretation of the determinants. So let's take an example. In order to understand the geometrical interpretation of determinants, let's take an example. The example is, let us suppose that we are told to find the area of a triangle. The triangle is ABC. We have only the coordinates of triangle given in 2D. The coordinate of A is 1, 2. This is x1, y1. And the coordinate of B is 7, 2. This is x2, y2. And the coordinate of C is 5, 4. This is x3 and this is y3. So these are the coordinates which are given to us, right? So these are not only coordinates. These are actually the vectors. These are actually the vectors. This is the triangle is formed by the vectors, right? So what is this A? A is nothing but is the vector in 2D from this point O to A. This is the vector, right? And what is this B? B is also the vector. 7, 2. It is from the origin O. This is the vector. This is the length of the vector. And what is this C? C is also the vector having x coordinate 5 and y coordinate 4. So this will be the length of this vector C. Okay, so these are vectors. Okay, so these are vectors. So now in this diagram, we are told to find the area of this triangle, right? But in order to find out the area of this triangle, we have to keep this thing in mind that we will find the area of this triangle by using the determinant property. So what is the determinant property? Let us suppose that in order to find out the area of this triangle, this is the vector. OA is the vector. Let us change the position of this vector from this point to this point. From vector, we mean it's a directed line segment. Vector is nothing but it's the directed line segment. We will transform from this vector OA from this location to this location. So what we get? This vector is initially at this point. Whenever we change the position of this vector from this point to this point, what we get? It will look like this. It will be here, right? And then thereafter we will join C point to this. It is like this. And we will change the position of this vector from this point to this point. We will transform this translational motion, right? From this point to this point. So it will look like this OA. Now what we will do? We will join these two. We will join this C to A and we will join this B to C. This B to C. So it will look like a parallelogram. OABC. This will be a parallelogram, right? So but we have to find out the area of this triangle. In order to find out the area of this triangle, which is made up of vectors, right? We will use the property of determinants. As we know that the value of the determinant, it gives us the area of the parallelogram, right? The value of the determinant gives the area of this parallelogram. But whenever we take the half the area of this parallelogram, we get the area of this triangle, because parallelogram is made up of two triangles, right? We can bisect the area of parallelogram into two triangles. Okay, so here in this case we will write down these vectors in determinant notation, right? So the elements of determinant are nothing but they are vectors on a Cartesian plane. The elements of or we can say the entries inside the determinant are nothing but they represent vectors on a Cartesian plane. Understand this point, right? Now we will find the area of this determinant. The area of this determinant is 1. We will write here. So we will cross multiply these two. 2 ones are 2 and 4 ones are 4. This is 2 minus 4. Plus minus in the same way here and plus in the same way here. So we will get 1 times 7 4s are 28 and 5 2s are 10 minus 10. Okay, but why 1 by 2 is here? This 1 by 2 is here because we are to calculate the area of this triangle. So that's why the entries which are in this bracket, square braces, they represent the area of parallelogram. So by the time we divide the area of parallelogram by 2, we will get the area of triangle. That is 1 by 2. Whenever we solve these terms, we get 13, and whenever we divide this 13 by 2, we get 6.5 centimeter square. So this 6.5 centimeter square, it represents the area of the triangle. Right? But this is an interesting number. Here the sign is positive. From this positive sign, that there is no orientation. In the area of the triangle. Orientation means from one place to another place. This is the one point. The second point is the case first. If we discuss here case first, if the area of, or we can say if the value of the determinant is 0, what we can understand from that very point, at that very stage, by the time we get the value of determinant 0, what we can understand at that point? We can understand that the vectors are linearly independent. So from the linear independence property of vectors, we mean that vectors lie on the same straight line. Okay, this is what we understand from the linear independent property. We can say that vectors are linearly independent whenever they lie on the same straight line or they merge at a single point. So these are some properties of the determinants in mathematics. Hope you have understood. See you in the next session.